sir. Ramesh sir. Okay. Amma, don't talk.
Greetings everyone. The conversation will be taken by Dr. Cmrec. She is working as an associate professor in CSC Data Science Department in Cmrec College. She is having more than 30 years of experience in teaching services in various engineering colleges. She also did research and attended for industry-oriented programs like Oracle 10. She did her PhD from reputed private university that is VELS Institute of Science, Technology and Advanced Studies, Valvaram, Chennai, Tamil Nadu, and M.Tech from JNTU Hyderabad and B.Tech from JNTU Hyderabad. She has guided many academic projects in UG and PG level, also with practical industry knowledge. Dr. B. Prashanti is NPTEL certified IoT, cloud computing, advanced computer networks, and operating system fundamentals faculty with elite grade. She was attended for numerous workshops, MPCC seminars, webinars, and training programs to equip learners with industry-ready skills, bridging the gap between academic and practical software development. Dr. B. Prashanti actively supports students in achieving academic excellence, industry certifications, and placements. Her teaching style motivates the students towards well preparation of subjects, hands-on learning, and integration of coding challenges and projects during. She is a good academic philosopher also. Now I request you to please come onto the dais and please speak forward.
Yes, ma'am. Good afternoon, everyone. So today we are going to discuss about linear regression, right? So today we are going to be discussing about contents like machine learning workflow model, types of machine learning, linear regression, simple linear regression, multiple linear regression, right? Okay. So first of all of you know, I think so. What is machine learning, ma? What is machine learning? Okay. So once again I will repeat. It is a field of study that gives computers the capabilities to learn from data and make decisions or predictions without being extremely programmed for a specific task. That is nothing but simply we tell as what ability to learn. So what happened here? The machine only self-learning. So that is nothing but what here machine learning. Without explicitly programmed, we are not giving explicit to computers. So that only is self-learning by itself. So that's why this is called what here machine learning. So what is the example for machine learning? Can anyone give it? What is the example for machine learning? So for example, if you want to search anything on Google, so for example, I want to search some bags. So list of bags, collection of bags will display there. So that is called as what here? Machine learning. So that will happen with help of machine learning itself, right? Next, how it will work internally. Okay, these are all examples of machine learning, right? Okay, so what is the flow of machine learning internally? So actually, what is the flow here? First of all, computer machine itself. What it has to do? Data collection, data preparation, choose model, train model, test model, make predictions, and improve model. So these are the flow will be followed by machine itself to give the output, right? So how it will? So first of all, we see data collection. So what is data collection here? We gather information. So first machine, so computer itself first collects the data, right? After that, data preparation. What it has to do? Clean the data. Like what? Nothing but remove mistakes, mistake values, organize to computer can understand it. Next, choose model. So machine itself choose the model according to the problem. So machine can itself choose the problem, right? So model is a math-based method that learns patterns. student works. For example, now we see one example, real-time example and test. Right? For this machine learning workflow, I am taking real-time example as student marks. Okay? For example, I am taking one section mark. In one section, how many students are there? 60 students. Okay. So now my task is to improve the student pass percentage. Right? So for that, what I have to do first? I have to collect the students' data. Right? I have to take total what 60 students' data. That is nothing but what here collect the data. Right? After that, what I have to do next step? What is the next step in flow of machine learning? What is the next step, ma'am? Data preparation. So what is data preparation? Remove the missing. Like for example, in 60 students, all are regular. No, some are irregular, like irregular. 10 students are there. So I have to remove all the data. Only who are the regular students who are submitting assignment, who are attending meets. So that students data only I have to gather. So that is data collection. After that, I have to do data preparation. After that, I have to apply the ML model. Okay? ML model is something but what we are in machine learning, we are using different algorithms now, right? Like supervised and we are using some algorithms, unsupervised we are using some algorithms, right? So these are different algorithms. Whatever the problem, according to your problem, you have to select the algorithm first. Okay? So after selecting model, so what is the next step now? Train one model. Okay, I have selected one model to improve that one class percentage, pass percentage. Okay, after that, what I have to do here? Train one model. So according to that model, to improve my class pass percentage, I have to train the students. Right? According to that, I have to train the students to improve the pass percentage. Right? So after that, test model. Okay. After testing, preparation train. I train students to according to that. What I did, for example, like increase the study hours. Okay. So like that, I have trained the students. After that, I will conduct test. Okay. So after that, make predictions. Okay. The trained model is used to what make predictions on it. According to my train, so I have predicted 90% of pass percentage I will get. Okay, that I have predicted, right? So after that, I will check the. After that, what I will do? After that, what I will do now? Improve the model. Okay, after result, I got, for example, 16% of pass percentage. What I have predicted? How much I predicted now? How much I predicted? 90% predicted. But how much I got? 60%. So accuracy is very low. So I have to improve the data. I have to improve the model. Like I have to increase the study hours time. Okay. According to that, students will improve the marks. So like if results are good, okay, 90 I expected, right? Okay, but I got 85% of students' result. So that is good. Okay, no need to improve. So according to our result, predict and accurate, you have to improve our result. So this is the best example for what machine learning works for, right? Right. Next. So what are the different types of machine learning? Supervised. Actually, there are 3 types of machine learning, right? Supervised machine learning, unsupervised machine learning, reinforcement machine learning. Okay, what is supervised machine learning? Supervised like what we are giving input as well as what This model tries to find pattern relationships or grouping the data on its own without being told that the correct answers are. So this is nothing but best example for what this one recommendation system, right? Reinforcement machine learning. What is reinforcement now? Reinforcement learning is a type of machine learning where a computer learns by trying things and getting feedback, a bit like how humans and animals learn from rewards and punishments. So what is the example for reinforcement algorithm? Self-driving car is the best example for what? Reinforcement machine learning, right? So now we supervised learning. How many segments? How many categories are there under classification and regression? What is classification? Classification is nothing but what here predicts categories. Regression is nothing but what here predicts numbers. So under classification also we use some algorithms. What are that? Logistic regression, decision trees, SVM, support vector machine, T-nearest networks, Navier space, random forest, neural networks. These are all under classification. So in regression, under we use some algorithms. What are that? Linear regression, simple. In linear regression, we will use simple linear regression, multiple linear regression, polynomial regression, return random regression. So in our session, we will discuss the regression. Okay. So what is regression? So what is the use of regression? Why we are using regression in machine learning particularly? So for what? Regression helps us predict one thing by using another thing is called as what? Regression. Okay? In this regression we will use two variables, dependent variable as well as what? Independent variable, right? So let's see here. In machine learning, regression helps the computer learn from past data and predict future values. That is important in machine learning. So what is machine learning? Explicitly program will load itself and give the output. That's why for this machine learning, regression is very important. Without this regression, machine learning cannot predict the output. That's why this is a very important. Regression is very important in the machine learning, right? Next, regression is a statistical approach to find the correlation between variables. That is dependent variable as well as the independent variable. Okay, madam, no problem. Madam, we are using ML model in the workflow of what based machine learning. So in ML model, at what time we will use this regression algorithm? Okay, at what time we will use this regression algorithm? You may have doubt. Okay, at what time we will use this regression means here? Regression algorithm gives continuous output. That means if you are asked to build a model that predicts the future outcome, then the output will be continuous, right? Then you must choose one of the regression algorithms to build your model. At that time, compulsory you should go with this algorithm that is nothing but what your regression. If you are expecting output, okay? So for example, first I want to build, for example, I am expecting some output. So which algorithm I have to use? Manufacture, you may have done so. Okay? First you have to understand your problem. Okay? So first you have to understand your problem. So what you are predicting output? Do you want number? Right? Do you want category? Do you want grouping? So that you have to analyze yourself. What you are going to be expecting output? You want member or category or grouping. So for example, if you want a member, at that time you go with this what? Regression itself. Right? For example, if you want category, at that time you go with the like K. Otherwise you go with the decision change is constant. Example, if study hours is increased, marks increase in a straight line rate. So that is the main best example for this regression. If you are studying more, you will get good marks. Otherwise, if you study only 1 hour, you got less marks itself. Sometimes you may fail also. So according to your study hours, your marks will be dependent, right? So this is the example for what you are linear regression. See here. In linear regression, perform the task to predict dependent variable value y based on a given independent variable x. So this regression technique finds out a linear regression between the x and y. X is here what here input. Your feature vectors are input, that is independent variables, and that will be dependent on your output, that is y, that is dependent variable, that is y. Hence the name is followed for here linear regression. Okay, dependent variable is continuous in nature. See here, linear regression indirectly means as the value of x is increasing, the value also increasing. For example, this is the x-axis. So x, this is nothing but what? Independent variables, independent of your features. Next, y is nothing but what? Here your output. So you are, for example, you take for example your student marks. Your study hours are here, will be placed in this. Your marks are here. While you are increasing your study hours, your marks also will be increased. So like this you get a line. So these are remaining your data points. This is a linear regression line. According to that you will get your output, you get your result, right? So based on the number of independent variables, linear regression is divided into two types. Actually, in this linear regression, so based on how many variables we are taking here? Two variables, right? So that is independent variable and dependent variable. So based on that regression, based on the independent variable, that is x-axis, depending on number, actually the linear regression will be divided into two types. What are that? Simple linear equation and multiple linear equation, right? So what is simple linear equation here? Y is equal to orthogonal plus orthogonal x1, or y is equal to mx plus c will be shown as this linear simple linear equation is nothing but y is equal to mx plus c, where m is equal to what plus tau, c is intercept or constant, right? Next, here how many variables we do? Independent variables, for example, this is y is nothing but your output, right? X is nothing but input. So this is y is dependent variable, x is independent variable. So here how many independent variables are here? Only one independent variable is here, that is x1. That's why this is what? Simple linear equation. Multiple linear equation you see, no? Y is equal to orthogonal plus orthogonal x1, orthogonal x2 up to orthogonal xn. So multiple independent variables will be used now. That is what? Multiple linear equation, right? So in simple linear equation we will use only one independent variable. In multiple linear equation will be used more than one independent variables. So that is the difference between simple linear equation as well as what? Simple linear regression as well as multiple linear regression, right? Okay, can you solve this example? If you can solve this example, I will give one example. Linear regression, right? Example for linear regression. Okay, first I am taking x and y. What is x here? Independent or dependent? Independent, very good. X is independent, y is dependent. That is nothing but output, right? For example, I am taking here x value 1, 2, 3, 4, y 3, 4, 5, right? So according to this problem, we have to follow the linear regression line equation. So first, you take multiplied by 3, 8, 3 by the 15, 7 for the 28. So this is nothing but what here? Sorry, x square now. This is x square. So 1 square 1, 2 square 4, 9, 16. So what to do here? Total. Okay? After that, how many inputs are here? How many numbers are there? M is equal to 1, 2, 3, 4. Is nothing here. It is equal to 4. Now, here I am taking A and B. What is A and B here? For example, what is the linear regression equation? Y is equal to mx plus c. So, in place of m, you are taking what here? What is the linear regression equation now? Y is equal to mx plus c. So, what we are going to be finding? Linear regression. Assume that m is equal to b and c is equal to a. That's why you are going to be finding the a and b value. So, what is the formula for a here? This is the formula for a. This is the formula for b. So, sigma 1, sigma square, okay, minus. In this formula, you have to substitute these values. X, y, x, y, x values, y values, x, y values, x square values. You have to substitute in this equation a and b. What is the sigma 1? Sigma 1, 90. Right? So 90. So like this you have to substitute these values now. Okay, already we have all these values in this, right? So according to that we have to substitute for it. So finally after you substituting the values, what is the a finally you got the value what? 1.5. Next. And see like this you have to substitute b. Right? So what is the b here now? What is the value? You got it? 1.3. Now, what is the regression, linear regression formula equation now? Y is equal to mx plus c. In that, in place of m, so we are using what? B, and in place of c, we are using a. So y is equal to a plus b, right? Okay. Now y is equal, what is the a value here? What is we got? 1.3 x, sorry, b value 1.3 x plus what is the a? 1.5. So predict y for x is equal to 10. Now what is the x total x value here now? Total x here 10. So predict y for x is equal to 10. So you have to substitute x in the value of here, right? Y is equal to 1.3 x plus 1.5. So you get here 13 plus 1.5 here 14.5. Right. If the value is whatever the value got, the predictable is accurate here, low or high, we can check. So take this value. Right. What is our original one value here? 3, 4, 5, 7. Right? So what are the original values of x here? 1, 2, 3, 4. Why predict value? How much value predict for each value? We can check here. So first of all, 1 plus 3 is 1.3 plus 1.5 is equal to how much value here? 2.8. Next is, first in place of x you substitute this value. Right? Next, what is the x value here? 2. 1.3 into x is 2, no? 2 plus 1.5 is equal to what here? 4.5. Next, you substitute in place of x value 3, you have to substitute here. 1.3 into 3 plus 1.5 is equal to 5.4. 1.3 into, next you have to substitute 4. So like it 6.7. So magnitude error. So what is our predict value now? First of all, 3. So how much you predicted? 2.9. How much error only. At that time, that is called as what? Linear regression. Straight line you will get. That is nothing but if you will get straight line, so that is nothing but what here? Linear regression. Your error is magnitude of it is very low. For example, you are writing exam mark. External exam you are writing. Okay. For example, one subject you wrote perfectly. So you are expecting I need 100 out of 100. But you got for example 95. Your prediction is correct or not? It is yes, no. Your prediction is correct or not? No. For example, you expected 100 marks. So otherwise, okay, you expected 95 marks. You got only 90 marks. Your prediction is higher or low? So little bit error is only 5 marks is different. No problem. Your prediction is correct, accurate only. So for example, you predicted 94 marks, you just pass the exam. So that is very different. So error is very high. So let us what to do. Yes, ma'am. Now we go with what here? Simple. Next we have already discussed the linear regression. Now we go with what? Simple linear regression. So what is simple linear regression? What is already I said equation. What is simple linear regression, ma'am? A simple linear regression model has only two explanatory variables, that is one dependent variable and one independent variable. So that is nothing but what we are simple linear regression. Okay, ma'am? So in dimensional what we are taking only one dependent, one independent and one dependent. So that is nothing but what we are simple linear regression. Think of two-dimensional space where the horizontal axis represents the independent variable x and the vertical axis represents the dependent variable y. That is, independent variable is our feature vector, dependent variable is output. Right? For example, student marks you take. For example, if you are studying more hours, you get more marks. Is it not? So like that, so compulsory whatever you are giving your feature vector, that depends on your output. If you are not studying anything, you will be failing. So compulsory you should give something input. At that time you will get some output. So this is nothing but what your simple linear. Only in this how many variables we are using? Only two variables, that is dependent variables as well as independent. So some assumptions will be used in this simple linear equation. So what are the assumptions? Linearity, independence, normals. So what is independence from? What is linearity? It assumes that the relation between the data points is linear. That is, the plot of the data points shows is linear. So compulsory both the relationship should be linear. Okay? At that time only we go with what? Linear regression. Independence. What is independence? There must be no relationship among the different values of the independent variables. That is, the value is unique. For example, in multiple linear regression, we are taking more independent variables. So all the independent variables should be unique itself. How many variables you take, no issue. But all should be what here? Unique itself. also you should understand the concept and you have to study. So then only you will get a pass, right? So that is the simple word here, best fit, right? Underfit is nothing but you may fail, okay? So only because sometimes you study on your failing subjects, but for what you are failing, you are not understanding the concepts. That's why you may sometimes fail. You are even study more hours, also you can fail. So that is the reason you are not understanding concept. If you understand concept and you study more, compulsory 100% you should pass the exam, right? That is the reason for your best fit. In this one, how to find the best fit? Like in this situation, currently we are trying to minimize the errors in prediction by finding the line of best fit. The regression line for the errors would be minimal. We are trying to minimize the length between the observed value y and predict value from our model y. Okay, so y is the observed value, y is the predicted value. To find the error also known as mean square error. So what is mean square error? So finding the error between what actual value and what predicted value. So that is the called as what here mean square error. So what is the formula for that? Here minimum of sum of y comma y whole square is the formula for what here mean square error. If you will get less error, we get best fit line. Okay? So if we error is less, no, we get best fit line. For the simple linear regression, what data pre-processing compulsory we should do? Fitting the model to the training data, predicting the result, and visualization. So what is data pre-processing? Clean the data using pre-processing techniques like transformation, normalization, encoding, genomic, or models given like accurate. So compulsory you should be pre-processing. If that comes, you will get accurate values. Fitting the model to the training data. After collecting data set, divided into compulsory there should be trained data and test data. According to that only your model will be worked, right? Whatever the model you are applying here, so that will be worked with help of this. Predicting the results, test the result. After that visualization, whatever you got the results, use it. After gradually you will draw the graph. How to improve your model? If you want to improve your model, you should normalize the data, remove offline, check collinearity. So, is the less error also we get accurate. So, again also we can improve our model with the help of these 3 steps. What are that? Normalize the data, remove outlines, check collinearity. According to this, we can improve our model. Multiple linear regression. So what is multiple linear regression here? Multiple linear regression is closely related to a simple linear regression model with a difference in the number of independent variables. Only difference between the simple linear and multiple linear is only what here? Only in case of independent variables only. Whereas a simple linear regression model predicts the value of a single independent variable based on the value of a single independent variable. In simple linear regression will be usually single independent variable, right? In multiple linear regression, the value of dependent variable is predicted based on more than one independent variable. So that is nothing but what here? Multiple linear regression. In this we are using what here? More than one independent variable. So that is the difference between what here? Linear, simple linear as well as multiple linear. So multiple linear regression equation is this one. Y is nothing here what? Output with that is dependent variable V0 plus V1 x1 plus V2 x2. So because here x1 x2 these are all independent variables. So that is the difference between simple linear and multiple linear. Here we are using more linear, more independent variables. What where y is dependent on prediction variable, V1 is the intercept, V1 V2 regression for
the leadership